Good morning. Today we are covering 6.1 operations with monomials, and your learning target is I can add, subtract, and multiply monomials. I do realize that I did not give you your notes packet, so you can either today follow along with this video and then rewatch it or look at the online filled out key for the notes later, or you can write these notes on a separate piece of paper. Or if you happen to have a printer at home, I know not everybody does, but if you do, you can go to your Google Classroom page, click on this 6.1 operations with monomials, and then you can print out the notes and worksheet over here. You can print this. So that's an option for you too. Hopefully we'll be back in school tomorrow and I can give you guys your notes packet, but I do want to get a start on this. So here we go. A monomial is a number or variable or a product of a number and variables, or just one. So we have some examples. You can have just a number or just a variable. You can have a product of a number and variable. It could look something like this. It could be multiple variables. Variables are just letters. You could have a fraction. You could have just a fraction by itself. Those are all monomials. They are single terms. Basically, there's no addition or subtraction. Monomials with the same variables and exponents are considered like terms. Now, we've talked about this before when we've tried to solve for a variable that you can combine like terms. The same thing is true here with these other monomials. So when we add and subtract monomials, to add and subtract these, we simply combine like terms. They must be alike for them to be able to be combined. We do not change the variables and the exponents. So when you're combining these, the variables and the exponents stay the same. So like I was saying, last semester, if you had a problem that looked like this, you would have seen that these two are like terms. You would have combined them. You would have gotten 9x. You didn't change the variable or the exponent. You just added the numbers. And then you would have solved for x. It's kind of similar here, although you're not doing the final solving. You're just doing the combining. So something to always ask yourself. Are they like terms? If you can answer yes, combine them. Okay, so we're going to do some examples here. We're not going to do all of these just for time. So we'll start out with an easy-ish one. We just did one similar to this, so we're going to skip that one. You can try it yourself or check the work on the key if you want to do it. We know that these two are alike because their variable is exactly the same. They're both k squared. So in this case, all you do is take negative 19 plus 2, so you get negative 17, and you keep the k squared. Like it says up here, do not change the variables and the exponents. We'll do another easy-ish one. If we're looking at this one here, you have to make sure that your variables are alike. So you have to make sure that we have r squared, s cubed, and t in both of these. And if they are alike, exactly the same, all you do is take negative 12 plus 4, you get negative 8, and then you do not change the variables or the exponents. You just bring them down. Number 4 is only slightly tricky because there's not a 1 here. but then we notice that the variables are the same, a, b squared. So all you do is take 27 minus 1, and you get 26a b squared. All right, I'll leave the rest of those simple-ish ones to you. And, just kidding. I want to do one more. Let's do 5. Check it out. Are these actually like terms? We have A, we have B, C. These are not alike, so we cannot combine. This is as simple as it gets. 7AB plus 4AC, that's it. Not like terms. Don't combine. Okay, so make sure you check in for that. 7 is a little bit tricky. If you can work with fractions, this one isn't too bad because the variables are alike. I know that to get a common denominator, to be able to subtract here, I'm just going to multiply by the opposite denominator. This is confusing to you. We'll get to more fraction stuff later this year, but this guarantees, because the denominators must be the same to add and subtract, that we end up with like denominators. Okay, they're both 12, which means I can actually now solve, and I get 5 over 12 x squared y. Like I said, if the fractions were confusing, don't worry too much about it. All right, 9 through 12, we do have a little bit more stuff going on. It's just that there are more than one monomial in these problems that we can combine. That's fine. Just make sure you know what's alike. So these two are alike because they are both y's, and these two are alike because they are both z's. So to combine these, 2 minus 11 is negative 9y, and 14z minus 10z is 4z. So you get this, and that's as simple as it gets. It doesn't combine any further. On 12, you'll notice I'm skipping around some. There are a couple things that are alike. We've got this guy and this guy that are alike. They're both a squared b. AB squared is different, so it will not combine. Technically, this is a 1 here, so we're going to have 9 minus 1, or 8a squared b, and then we bring down the thing that is not alike, and this is as simple as it gets. All right, if we go down to these word problems, they're not really anything crazy. All you have to do is follow what it says. So like sum is addition, difference is subtraction, and subtract is subtract, okay? So we're just going to do 2 of these. We will do the sum one, so find the sum of these 2. That just means add them. Now, because the 1 is a negative 9z squared, that actually kind of like wins in a battle between positive and negative. So we have 14z squared minus 9z squared. This is just going to be 5z squared. So even though this was a plus here, that negative kind of wins out. And then if we do the difference, find the difference of 13a squared b and negative 5a squared b. They are alike. A squared b is the same. Those won't change. But when we write this out, we have 13a squared b minus negative 5a squared b. The minus and negative, guys, will become a positive. That's just a rule in math. So you end up adding these, even though that's not what it asked us to do, okay? So you have to really pay attention to how the problem's worded and set it up accordingly. So you end up with 18a squared b. So that's addition and subtraction of monomials. You make sure that the terms are alike, and then you combine them, and you don't change the variables and the exponents. Now we're going to continue to multiplying. So to multiplying monomials, you use the product rule, okay? So for the product rule, you have your base, x, okay? And then you have exponents, in this case, a and b. The base has to be the same. So you're going to end up with x, and as long as they're the same, you add the exponents. Okay, so another little rule over here to ask yourself. Are the bases the same? If yes, use the product rule. Okay, so think through these ones with me. Because these two x bases are the same, the product rule tells us to add our exponents. So this is x to the sixth. And notice we are multiplying now, not adding. So our exponents, they don't have to be alike this time. For the next one, our bases are the same. They're both a. Technically, an a by itself is a to the first power. So you're going to take a for plus 1. That's a to the fifth. If you think about an exponent, guys, a to the fourth is technically just a times a times a times a. And then you have one more for this next thing, times a. That is 5 a's, which is where we get a to the fifth. So you can think about things that way. You could do the same thing with the w's over here, although you'd end up writing out a bunch of them, because w to the 5 plus 9 is w to the 14. So that would be a lot of w's to write out. But you could, if you like seeing it that way. So we have examples with coefficients now. Coefficients are just the number in front of the variable. I'll say the letter, so that way you really know. It's just the number in front of the letter. So coefficients work like normal. You just multiply them because that's what they're being asked to do. And then you simplify the variables with the product rule. So for example, 20. You just take 3 times 7 because they're being multiplied, right? So 3 times 7 is 21. And then you work with the product rule on your variables. That's x to the 3 plus 2, or x to the fifth power. You don't always have to do this if you do not want to. If you can do that in your head, that's fine. Now let's look at 21. It looks a little bit different. There's no dot in between to signify multiplying, but if two parentheses are smushed up by each other, that means they're being multiplied. So take negative 8 times 2, that's negative 16. And then for the product rule, you take 7 plus 3. That's m to the 10th. And you're done. Skip down to 24. More things are going on. That's fine. Multiply your numbers. So negative 2 times negative 9 is 18. Use the product rule on your p variable. So we have p to the 11th, because 7 plus 4 is 11. We'll have q to the 7th, because 5 plus 2 is 7. And we will have r to the 4th, because 1 plus 3 is 4. So you just look at each individual variable, make sure the bases are the same. Skipping down to 27. Multiple things going on here. That's fine. We're going to take 1 times 8 times negative 1. That just gives us negative 8. We look at our m's. Oops, wrong thing. We have m to the first, m to the second, and m to the first. So this gives us m to the 4th. And then we have n's. N to the first, and n to the 9th, which will end up giving us n to the 11th. All right, keep moving forward. We're going to skip down to 29. So we have to multiply our numbers, 9, 5, technically there's a 1. So this will be 45 with our numbers. Those should be easy. Just treat them like normal numbers. We have p squared, and there's no p in the last term, so don't worry about that. We just end up with p cubed. And then in the first term, there is no q, so we will end up with q to the 5th. Okay, 2 more to go. We're going to do 34 together, and then we're going to do 38. So 34, there's a bit of a fraction. That's okay. You're just going to take 1/3 times 2 times -15. You can do that in your calculator, or you can take -15 divided by 3, whatever you want. Those 3 multiplied give us -10. Then we look at our x values. We've got x to the 1st and x to the 7th. Add those exponents, we get x to the 8th. And then, lastly, we look at our y's. You have y to the 3rd, y to the 1st. Add 3 and 1, you get y to the 4th. All right, last one. We need to split this into 2 parts. We need to work with the first 2 terms and the second 2 terms because this is technically like one monomial that we can simplify. This is another, and then they get subtracted. So working with the first half, we will take -8 times -4. That's 32. We look at our c's. We have c to the 5th, c to the 3rd. That's c to the 8th. Then we have d to the 1st and d to the 4th. That's d to the 5th. Bring down that minus in between. Look at the second half. We have 9 times 3. That's 27. We have c to the 7th and c to the 1st. That is c to the 8th. And d to the 2nd and d to the 3rd. So that's d to the 5th. Now notice we're combining both multiplying and subtracting here. So we did the multiplication steps. Now we need to check, are these like terms? They are both c to the 8th, d to the 5th. So we can finish simplifying these by taking 32 minus 27. That is 5. And then the variables do not change because we are subtracting. They stay exactly as they are. So that's our lesson for today. Like I said, I know you don't have the paper. Hopefully you were able to follow along and you'll be able to write this down at a different time. I am planning on giving you the packet tomorrow, and we'll keep going with the next section, 6.2. Email me if you have questions, or if it's still within your class time, you can hop back on to the Google Meet and ask me anything that you need. Have a great day.